Hey everybody, how's it going? Welcome to day three, I guess technically day four because I'm recording it a day late. Day three of the Advent of Code video series. I'm planning to knock out problem three, and as you can probably see from the timestamp here, problem four is just around the corner. So if we can finish this in 42 minutes, we might be able to start problem four, which will be the next video right away. So let's see how we do. For those of you who haven't seen any videos in the series yet, I'm Ryan. I'm a web developer, and I'm using a language called Elm, which compiles to like HTML and JavaScript. And we're going to be solving the problems in the web browser using this great website called Ellie. It's kind of like the code pen for Elm, and we're just going to be printing stuff out. So this is a little template that I have in the beginning of most of my videos where we're just doing some basic just printing stuff out to the screen. So this debug.toString allows me to print out any type of value. So that's what that's all about. So what we're going to do is we are going to get started. We're going to click on problem three. I haven't seen it yet. There's two parts to every problem. And what we're going to try to do is solve it. And I'm just going to walk you through kind of my thought process, and we'll get there together. So that's it. Let's dive into it. See how it goes. Cool. Rucksack reorganization. All right. Let's see what our elves are up to now. One elf has the important job of loading all of the rucksacks with supplies for the jungle journey. Unfortunately, that elf didn't quite follow the packing instructions, and so a few items now need to be rearranged. Each rucksack has two large compartments. All items of a given type are meant to go into exactly one of the two compartments. The elf that did the packing failed to follow this rule for exactly one item type per rucksack. The elves have made a list of all of the items currently in each rucksack. That's our puzzle input. But they need our help finding the errors. Every item type is identified by a single lowercase or uppercase letter. That is, lowercase a and uppercase a refer to different types of items. The list of items for each rucksack is given as characters, all on a single line. A given rucksack always has the same number of items in each of its two compartments, so the first half of the characters represents items in the first compartment, while the second half of the characters represent items in the second compartment. Okay. For example, suppose you have the following list of contents from six rucksacks. So these are all just examples. So the first one contains the items V, blah, 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 P, which means the first compartment is just going to contain the first half here, so this V to R, while the second compartment contains the items from the other half, so H to P. The only item type that appears in both compartments is lowercase p. Okay. The second rucksack's compartments contain this and that. The only type that appears in both is L. The third rucksack's compartments contain P to V, da 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 da. Only common is P. Okay, so we're trying to find in the first half of the backpack and the second half of the backpack, what letter do they have in common? Help prioritize item rearrangement. Every item type can be converted to a priority. Lowercase item types A through Z have priorities 1 through 26. Uppercase item types A through Z have priorities 27 through 52. The above example, the priority of the item type that appears in both compartments is 16. Okay, got it. And they sum up to 157. So find the item type that appears in both compartments of each rucksack. What is the sum of the priorities? Okay, great. Okay, so this is kind of crazy. Let's start by getting this puzzle input in here and just printing it on the screen. That's how all my videos start, where we just start by making a string here, just to capture the values that we got from our puzzle here. So I'm using string.trim so that all these new lines go away. Here, oops, and then let's actually print out the puzzle input to the main function, which is gonna control what gets printed out over here. Okay, cool. So I'm gonna break these up into lines real quick just to show you that each item here, this is each. It's a single backpack. So what we want to do is we want to split these into two. So the example they had, I think this was the first half, and this was the second half. So I think what we want to do is for each item in the list, we're gonna have a two rucksack function. So two rucksack is gonna take in this like raw string here, So it's going to take in a string like VZ, blah, 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 all that stuff. And then we're going to turn it into a new value. We're going to call that a rucksack. And all a rucksack is going to store is the first compartment. So this is going to be a rucksack is just a nickname for a record that has slot 1, I guess, or compartment 1. And that's going to be a string. Slot 2 also going to be a string. So our mission for now is to take that string that we get. So for each item in the list, that's going to be one string that comes in, and we're going to try to turn it into slot 1 and slot 2. So we can do that by getting the length, which is how long each string is. And then I think what we want to do is say slot 1 is string dot, is it take left, or is it, I think it's just left. So length divided by 2. Let's try this out and see if this is okay. String dot right length divided by 2. Let's see if this gets us what we expect here. So string gives us a rucksack length string. Oh, and I need to say what string I'm taking stuff from. So this is the input string here. Okay, cool. So I'm seeing V through R and then H through P. Let's take a look at the sample puzzle. So we have V through R, H through P. This one's J through L and R through L. J through L and R through L. Okay, great. P through V and V through G. I think we're in good shape. I think, so the first step of splitting each of these lines into a rucksack, which is just like a list of these characters, is working well. I also think instead of using a string, what we can do is we can make this like a set. So there's a few data structures that come built in with Elm. There's like lists, there's dictionaries, there's sets, there's arrays. You can check out all these, all the docs for these in the core library here. So array is what you might be used to in JavaScript, being able to easily access values at a given index. Dictionary is like a key value map. So you might use like an object in JavaScript for this. And then a set is also a type. What's cool about sets is you can have like unique values. And so we can insert stuff into a set, and we can also make a set from a list and ask like, hey, are there any intersections between these two sets? So for example, intersect would give us all the things that the two backpacks have in common. So let's just make two common items. Let's make that. So what two common items is going to do is it's going to take a rucksack. That's what we left off here. So when we first got our puzzle input, it was a string. When we called string lines, what we did is we ended up making a list of strings. And then when we used list.map with toRucksack, it took the list of strings and turned it into a list of rucksacks. And now what we're going to do is we're going to have a list of common items. So this is going to be a list of sets of characters, okay? So a character is going to be like V or J, uppercase J. And we're just going to return all the matches that we found. So in order for this to be happy, we're going to need to make two common items. It needs to take in a rucksack. And for each rucksack, it's going to return the set of characters that they both have in common. So we're going to have like slot 1, slot 2. What we want to do is we want to first take slot 1, which is a string. We're going to turn that into a list of characters. We're going to turn that list of characters into a set of characters. And then we're going to use set.intersect to find out between the two groups which values appear in both sets. So let's try that out. So first I'm going to say, I'll do set.intersect, intersect. Our first set is going to be slot 1, but I'm going to do string.toList. So that gives us a list of characters. And then we're going to say set.FromList. And so if I do that twice, hopefully oh, that's right. I need to make sure to import the type. So I imported this module. I need to also expose the type. Otherwise, for my definitions, I'm gonna need to like fully qualify the import. So we're gonna do that so that we have access to the set type. Great. Oh, and it looks like I copy pasted slot 1 twice. And so what we're seeing is the intersection is literally every letter they both have. So that was a mistake. But here, what you can see is we do have a list of these sets here. And we're going to be able to take those values and kind of sum up what they are. So for example, now that we have this set of characters, what we can do is we can basically like convert each set, do a set.map. We could say like toPriority. So we'll have a toPriority function that takes a set of characters and gives us back a set of integer values that we can add up, which I think will be really useful. So toPriority is the next function that we're going to write. I'm going to do this. toPriority is going to take a character and it's going to give us the value of the character. So yeah, so if you give me, let's take a look at the puzzle. So A through Z has 1 through 26, and then A through Z here have priorities 27 to 52. And if we get like an invalid character, I think I'm just going to make the priority 0 in that case. We're going to have to figure out how to handle that, because that's something that's technically possible to get. Like if there was like a question mark in the middle of this string, we'd have to tell the program to handle that. So for now, what I'm going to do is I'm going to say, let's take a look at the docs for characters. Let me zoom in a bit. And let's see, there's something that turns characters into integers. So you can see 65 is the default value for A, just based on like the Unicode like value. So I think what we can do is we can take the characters and just convert them to their integer forms and then subtract a certain number from that. That might be a little bit crazy, but hopefully it'll be an efficient way to write it so we don't have to like write like 52 different conversions, say like A is 1, B is 2, that kind of thing. So let's make sure that we know what this needs to be. So 1 through 26 and 27 to 52. Okay. So what I'm going to start with is let's just pretend that char to code is the priority we want. So here you'll see I have 112 for P, but I shouldn't have that. So this is going to be like the Unicode int. So this is Unicode. And I can say if char dot is lowercase, then we're going to have to subtract a certain amount from that. So it looks like capital A is 65. So maybe we'll start with is upper. Is upper the function, or is it? It's is lower and is upper functions here. So we're going to say so char dot is upper. We'll do something here. And then if there's anything else, if we get any garbage in the list, we're just going to turn it to a 0 and kind of that'll make it ignored in the sum. So I think that would be good. It's a good way to handle it without like needing to return like a maybe type or something like that. Okay, so if we do have an uppercase character, what we want to do is we want the uppercase characters. So A, for example, we want that to be worth 27. But what this is going to do is this is going to make that equal 65. So what we should really do is we should subtract the Unicode int value. So Unicode int, we're going to subtract 65, so that's going to bring it back down to 0 for A, and then we're just going to add 27. I could do the math and like make that one number, but I think for readability, I'm going to keep these as 2 separate values. So Unicode int minus 65 is going to bring us back down. One thing that I do want to test is, let me just do that, and then hopefully this will tell me what the Unicode int value is for A. So it looks like it's 97. So this is a little trick I did so that when we split this rucksack into two letters, it would say that A was the intersection. So you'll see that this was just a quick way for me to figure out what A is. And then when I add this back in, now I can know the code for A, even though lowercase a isn't in the docs. So this is just a little sneaky way for me to learn that A was 97, so that I could say minus 97 and then plus 1. So we should see a 1 here for the value when A is the overlapping number. And similarly, we should see a 2 here all the way up. So we can test that Z is 26. Looks good. We can test that capital A's are 27. Awesome. Capital Z's 52, and I'm pretty sure that's what it was. Yeah, it's supposed to be 52. Great. And then finally, if we put in some garbage input, our program's not going to crash. It's just going to give us 0. It's going to say, hey, that's not a valid priority, so we're just going to say the priority is 0, or it's not defined for this program. Great. Okay, so I'm going to add just some comments here. I'm going to run this format. I add some lines when I'm recording these videos at the bottom so that my scroll bar doesn't have the puzzle input all the way at the end. Anyway, so it looks like we have 16, 38, 42, 22, 20, and 19. And that's what we have here, 16, 38, 42, 22, 20, and 19. And then the last step, I guess, is to sum all these numbers up to 157. So we've got like a list of sets of numbers. So let's start to like unwrap that. Let's just make some functions that unwrap all that crazy stuff. So I'm gonna do this to keep so that while you're following the video, you can see what these types are. I'm gonna keep these around. Format kind of wrapped them on a new line for me, which is not really what I want, but that's okay. All right, so we're left with a list, which is a set of integers. So what I want to do is I want to start by just saying, let's turn this into a list, and then let's sum up that list. So I'm using kind of a cute operator here. This greater than combines two functions together. That's not something you really need to know how to do, but this is a way to basically just do two conversions. If we want, we could give this a name. We could say like this is add up numbers in set. So this is generally what I would prefer to do. Oops, sorry about that. This is generally what I would prefer to do because when I'm writing code, especially like when you're working on a team, it's a lot nicer when you just give things names so that the person who's reading the code can understand what your intention was. Even if you don't get the code right, they at least can kind of read what you were trying to do. So I was just trying to get my set of integers into a single value. So what I'm doing is I'm saying set.toList. Now I'm going to pipe that into list.sum. That way we don't need to use this fancy greater than. At work, I work with a lot of really talented like front-end Elm engineers, but I also work with a lot of talented back-end engineers who aren't familiar with Elm syntax. And so sometimes they just want to hop in, like fix a bug or like add a feature or something. And so I try to reduce the amount of like special characters that I throw and, you know, new things for them to learn. So I try to keep stuff as simple as possible when I write my Elm code. Okay, this got reformatted, that's okay. Now that we have this, we have a list of ints, and we can add them all up with another call of list.sum, which will just add up all these numbers. And that gives us 157. So here we are, we've got the number that the puzzle was looking for. And so what we're gonna do is we are gonna get our puzzle input. I signed in to Admin of Code with my GitHub, so my puzzle input is gonna be different than yours. But the idea is, I'm gonna just do this for the link in the video. Every time I solve a problem, I'm gonna include the solution in the description for the video below, so you can check it out. So I'm just gonna add some of these back in so that you're gonna be able to kind of see the types here. So I'm gonna do this one last time. I gotta stop hitting format because it's messing up my little annotations. So I'm gonna save this. I'm gonna run it, make sure it's still 157, great. And now that I have this link, I'm just gonna copy this so I don't forget to include it in the video. So I've got a little notepad off to the side here. Okay, so again, we're going to copy this and we're going to use our actual puzzle input and see what number we get. We get 8252, and let's see if we get our star. Woohoo! Okay, we did it good. Every day there's a part 1 and a part 2. Let's take a look at part 2, and it's usually some like little twist that reuses a bunch of the code that we already wrote. Okay, so part 2. As you finish identifying the misplaced items, the elves come to you with another issue. For safety, the elves are divided into groups of 3. Every elf carries a badge that identifies their group. For efficiency, within each group of 3 elves, the badge is the only item type carried by all 3 elves. That is, if a group's badge is item type B, then all 3 elves will have item type B somewhere in their rucksack, and at most, 2 of the elves will be carrying any other item type. The problem is that someone forgot to put this year's updated authenticity sticker on the badges. All of the badges need to be pulled out of the rucksacks so that the new authenticity stickers can be attached. Additionally, nobody wrote down which item type corresponds to each group's badges. The only way to tell which item type is the right one is by finding the one item type that is common between all 3 elves in each group. So every set of 3 lines corresponds to a single group, but each group can have a different badge item type. So in the example above, the first group's rucksacks are the first 3 lines. The second group's rucksacks are the next 3 lines. In the first group, the only item type that appears in all 3 rucksacks is the lowercase r. This must be in their badges. The second group, their badge is Z. So if we add up, okay, so this is, got it. So we're going to try to find the intersection of all 3 of these. And so R is the only thing that they have in common. And so once we do that, we're going to get R. We have that toPriority function already that converts that to the number. And then Z for the second. So great. So let's take, undo this so we get our simple puzzle input back in. And let's rewind back to where we were over here. So I'm going to just kind of delete these lines of code. They're not that important. The more challenging stuff is already written here. So let's go back to what we have. Cool. So this is a list of strings. But what I want to do is I want every 3 items to be grouped together into one like group. So rather than having this like rucksack stuff, this is like part 1 code. We're going to have some part 2 code that we need to do. So a group has a rucksacks, which I guess you can think of them as a list of strings. We don't have to convert them to this if we don't want to. So what I think I want to do is I want to end up with a list of groups. So let's make something that does that. So what in Elm is a good way to take a list, split it into 3, or group 3 items together. I think what I want to do for this is I'm going to want to reach for this list extra package. So Elm, just like NPM, has its own like packages that you can find. So there's a popular like Elm community packages that have like additional functions for doing more complex things that don't ship with the core Elm library. So if you need to do like fancy stuff with lists, there's this list extra thing with a bunch of these convenience functions. So you can say groups of 3, and then look at that. That function's already there. So I can just call list.extra.groups of 3, and then we'll end up with a list of lists. So let's do that. Let's import list.extra now that we have it installed here. You'll see that it's a part of our dependencies. As I do list.extra, I can do with this. I can say list.extra groups of 3. And this is going to give us a list of strings because it's going to break the lists apart. So now we'll see that there are 2 items here. There are 2 groups here. We've got group 1, which is these items in their backpack. And then we have group 2, which have, or I guess these backpacks. So a group, we can just call this a list of strings if we want. We can say group is an alias for list of strings. And then what this means now is we have a list of groups. So with each group, what we want to do is we want to do the exact same logic we had before. We want to get the intersection across everything. So what we can do is we can say we need a new function, which is going to be find common items in group. You give me a group, I will give you a set of characters. So how are we going to get that set? So I think what we want to do is we want to do a we kind of want to just like go through each item and then return what we have in common. I'm trying to figure out if I want to use a fold for this or what. I think I'm going to use something called a fold L. So fold is kind of like reduce, and what it's going to do is it is going to get the intersection of all these items. So we're going to have like find intersection. That's going to be a function. So find intersection. What this is going to do is going to take in a string, one string at a time, and what we want to do is we want to get give it the existing set of characters, and then return the new ones. So right now this isn't doing anything, but if we had an empty set and we looped through all the rucksacks for that group. Oh, this needs to be a set. I can say set.frontList. Remember, a group is a list of strings. So what this will do, hopefully, when we're done doing this, is return the intersection for everything. We have a problem here where we need to grab the first item. So if we have an empty list, we're gonna have an empty set. Doesn't really matter. But if we have a first item, or a first rucksack, and then we have like the rest of the rucksacks. Really what we want to do is instead of using an empty set and finding the intersection, we're going to want to do this. So the first rucksack is a list of strings, or sorry, it's a single string. So what we want to do is we want to say to set from string first rucksack. We could just call this to set to be convenient. But to set is just going to be a local function that we have. It takes one of these rucksack, like all the contents of the backpacks, and it's going to give us back a set of the characters that it found there. So if we have this is just like what we did before. This is literally just going to be this function. So we'll say, if you give me a string, we're going to turn that into a list of characters, and then we're going to turn that list of characters into a set of characters, which is what the function's expecting. And so all we're going to do here is kind of loop through the rest of the rucksacks, and we're just going to find the intersection. So if we do set.intersect, and we try to intersect the existing set, so the matches we found so far, with toSet of the string. So each time we loop through, hopefully we'll kind of make the groups more and more concise. What I want to do is I want to call find common items in group, and I think this is a list up here. So at the end of this, I'm going to end up with our list of sets of characters, just like we had it last time. Rest of the rucksacks. Oh, that's right. I need to turn this into a set. Okay, so all of that typing, and we got the 2 letters. So that might be a little anticlimactic, but yes, R and Z are the correct answers to this. So we get to reuse the code that we had from before. The code we had from before was able to call add up all the numbers or something. Add up the numbers in the set. Oops, list.map. Find common. Add up numbers in set. Oh, that's right. We have to turn them to their priority, and then we can add them up. Map, set.map to priority. So I'm just going to comment this out so that we make sure that we're seeing the steps in the right order here. So that's going to give us 18 and 52. We're going to add up all the numbers that we get in that set, which leaves us with 18 and 52. And then finally, we're going to use that list.sum again to add them back together. And it says 70 here, and it looks like that's the right answer here. So that's part 2. So I'm just going to rename this to part 2 here. I'm going to add some comments here so that we can remember what we're dealing with. So this is going to be a set of ints. Here we're going to have a list of ints, so we add up all the numbers in each set. And then finally, int, and that's the answer to the puzzle that we did. So I'm going to save this again. Copy that for the video description, put it over here. And let's see if it's right. Let's take our same puzzle input. Let's go down here. I'm going to put my input in here, and we're going to see what that final answer is. 2828. That's a pretty number. All right, we did it again. So we got 6 stars. That's day 3. Yeah, the solutions are in the video below. Right after this, I'm going to dive into day 4. You're going to see me wearing the exact same outfit because what time is it? We got 10 minutes until... All right, so in 10 minutes, you're going to see me kick off the next video because that's when day 4 is going to be ready. Yeah, thanks for watching. The links are in the description below, as well as links to Advent of Code, links to like the Elm guide if you're trying to learn more. And that's it. I'll catch you next time. And thanks for watching.